Hello everyone and welcome back. I'm Benjamin Williams and today we're still within the infrastructure section within Boson NetSim. Today's lab will be on GLBP or Gateway Load Balancing Protocol number 2. As we know, Gateway Load Balancing Protocol is a Cisco proprietary first hop redundancy protocol. So let's go ahead and get into our lab objectives for this lab. It says in this lab, you will configure and verify a basic Gateway Load Balancing Protocol GLBP environment. Gateway Load Balancing Protocol is a first hop redundancy protocol, FHRP, that can be used to ensure the immediate and transparent recovery from first hop failures in network edge devices by providing gateway redundancy for IP networks. You will also configure GLBP authentication. Okay, so we'll be configuring regular GLBP and GLBP configuration in this lab, GLBP authentication in this lab. Of course, you will want to configure authentication on your devices to keep rogue devices from joining the GLBP group. Okay, so let's look at our lab topology. If we look at our lab topology, we have an ISP router up here at the top. We have 3 routers right here, R1, R2, and R3. These will be the devices that we are configuring GLBP on. As we know, one of these routers will be the AVG or Active Virtual Gateway, and that will be in charge of the load balancing. And by default, as we know, GLBP uses round robin. The round robin algorithm for load balancing. So round robin goes in the sequential order. So it will go R1, R2, R3, and then it will go R1, R2, R3 again. Okay. We have our access layer switch, and our access layer switch has 3 PCs connected to it. And of course, our access layer switch gives our PCs access to the network. Okay. So I've already read through all of the commands and descriptions for this lab. So this is always good information to have. Also, I've went through all of the IP address information for each device. And this is good information to have as well for troubleshooting purposes, and to also make sure that all of the interfaces are configured with the correct IP address and also subnet mask. All right. So we will be doing all of our configuration down here at the bottom. We'll be doing, we'll keep our topology up here at the top left. And we'll be doing all of our readings right here, top right. Okay, so let's get into our task number 1. It says configure gateway load balancing protocol. It says in this task, you will configure gateway load balancing protocol group 10. R1 should be the active virtual gateway, AVG. You will also configure gateway load balancing to ensure that data from hosts is load balanced across the GLBP routers in a round robin fashion. Okay, so we're going to leave it at the default, which is round robin. Let's get into task number 1. It says on R1's Ethernet 03 interface, configure GLBP group 10 with a priority of 110. So we're on R1 now. All right, and we're doing enable to go into privilege exec. Let's do a configure terminal to go into global config. Let's go into interface Ethernet 03. And we're going to do a GLBP group number of 10. And we're going to configure the priority to be 110. Okay, that looks good. Let's go ahead to move task number 2. It says on R1's Ethernet 03 interface, enable AVG or Active Virtual Gateway preemption for GLBP group 10. Okay, so let's do a GLBP 10. 10 preempt. All right, it looks good. Now it says on R1's Ethernet 03 interface, configure GLBP group 10 with a virtual IP address of 10.10.10.25 and start the GLBP process. Okay, so let's do GLBP 10 IP 10.10.10.25. Looks good. Let's hit enter there. All right, now let's go into task number 4. It says on router R2 Ethernet 03 interface, configure GLBP group 10 with a virtual IP address of 10.10.10.25 and start the GLBP process. What difference do you notice about the debug output when compared to the output on router 1? Okay, so we can see that GLBP here has now started, and it has went into the active state for the virtual forwarder number 1, as we can see. All right, so let's go to R2. Let's do an enable. Let's do a configure terminal. Oops, configure terminal. It's going to interface Ethernet 03. Let's do a GLBP 10. And we want to do an IP address of 10.10.10.25. All right, and let's give it a second. Give it a second for our debug message to come up and the CLI. And we'll compare the output to R1. All right, so we can see that the difference between the outputs is that this output is saying that it is the virtual forwarder for number 2. So it's the virtual forwarder for the MAC address of the second forwarder. And R1 is saying that it is the active virtual forwarder for forwarder number 1. As we can see, that is the only difference between these two outputs, okay? So this is the active virtual forwarder for number 1, and this is the active virtual forwarder for number 2 right there, okay? So right here it says, on R2, display brief summary of GLBP configuration. What is R2's virtual gateway state, okay? So let's go right here. Let's do a do show GLBP brief. All right, and we can see that it is in the standby state for the AVG or the virtual gateway status. It is the standby, and R1 is the active, okay? So right here, number 6 is saying, on R1, display a brief summary of GLBP configuration. What is R1's virtual gateway state? Well, if we go over to R1, let's go over here. Let's do a do show GLBP. Oh, well, let me just do, I meant to say GLBP brief. Oops, brief. There we go. We can see that the AVG status for R1 is the active. Okay, so it is the active. And we can see right here that R2 is the standby. Okay, so it says on R2, display detailed information about GLBP configuration. What is the state of the AVG preemption of GLBP group 10? So if we go to R2 and we do a do show GLBP, we should do a do show GLBP, we can see that the preemption state is in the disabled state for R2 because we didn't enable preemption on R2, okay? All right, let's go to question number 8. It says on R1, display detailed information about GLBP configuration. What is the state of active virtual gateway preemption for GLBP group 10? So if we go over to R1 and we do a do show GLBP, we can see right here it says the preemption is enabled for the AVG, okay? Because we enabled that earlier in our output in the CLI right here. We enabled preemption right there, okay? So it is enabled on R1, but it's not enabled on R2. All right, so let's go to R3. It says right here for question number 9, it says R3's, it says on R3's Ethernet 03 interface, enable AVG preemption for GLBP group 10. So let's go to R3. All right, let's do an enable. Let's do a configure terminal. It's going to interface Ethernet 03. And let's do a GLBP 10. And it wants us to enable, 10 preempt. Okay, looks good. All right, it says right here for number 10, it says on R3's Ethernet 03 interface, configure GLBP group 10 with a virtual IP address of 10.10.10.25 and start the GLBP process. All right, so let's do GLBP 10, IP 10.10.10.25. All right, that looks good. All right, right here it says on R3, display detailed information about GLBP configuration. Why has R3 not assumed the AVG role? Okay, so let's go and do a do show GLBP. All right, and we can see that it is now the standby router, and it has not assumed the AVG role because the priority for R3 is the default, which is 100, and R1 has a priority, as we can see, of 110. So R1 has a higher priority than R3, and that is why R3 is the standby and R1 is the active. As we can see, it says active right here. All right, so that is why R3 has not assumed the AVG role. So number 12, it says on R3, examine the detailed information about GLBP configuration. Why is R2 no longer in the standby role? Well, if we take a look at R3, it had, we actually enabled preemption on R3. So that is one of the reasons why. And also the other reason why is if we look at the actual IP addresses themselves, we can see that R2 was configured with an IP address of 10.10.10.2, and R3 has an IP address of 10.10.10.3. So they both have the same priority values, but R3 has a higher IP address configured on this Ethernet 03 interface. So that is why R3 is now the standby instead of R2, okay? So number 13 is saying on PC1, PC2, and PC3, configure each host to use the GLBP group 10 virtual IP address as a default gateway. All right, so let's change the default gateways on each of the PCs. We're going to do an IP config / default gateway of 10.10.10.25. All right, let's do the same thing on PC2. Let's do an IP config / default gateway of 10.10.10.25. All right, do the same thing on PC3 lastly. Let's do an IP config / default gateway of 10.10.10.25. Looks good. All right, number 14, it says on PC1 and PC2, trace the path to ISP 203.0.113.56. What do you notice about the path that traffic from PC1 takes through the distribution layer in contrast to traffic from PC2? All right, so first, what I want to show you guys is what IP address is 203.0.113.56. So 203.0.113.56 is the loopback 0 interface on the ISP router, okay? So that is the loopback 0 interface on this router up here. And as we know, as I said at the beginning of the video, GLBP uses the round robin algorithm. So basically what that means is PC1 is going to use R1, PC2 is going to use R2, and PC3 is going to use R3. So these end devices will load balance their traffic to a different router because we're using the round robin algorithm, okay? So if we had PC4, it will use R1, PC5 will use R2, and PC6 will use R3 if we had more PCs. That's the way that the round robin algorithm works. Okay, so let's confirm that. Let's go to PC1. Let's do a trace RT to 203.0.113.56.113.56. All right, so we can see that the first hop for PC1 is R1. All right, now let's look at, we can confirm that with our IP address table quickly. We can see that is the IP address on R1 right here. R1 is Ethernet 03 interface, has an IP address of 10.10.10.1. All right. And if we go bring our topology back up, let's go to PC2. Let's do a trace RT to 203.0.113.56. And we can see that PC2 uses R2 as its first hop. All right, so that has an IP address of 10.10.10.2. We can confirm that. Right here it says R2 is Ethernet 03 interface, has an IP address of 10.10.10.2 right here. Perfect. All right. So if we did the same thing, a trace route to from PC3 to the ISP loopback 0 interface, PC3 will use R3 because, like I said, we're using the round robin algorithm. Okay. So let's go ahead and move on to task number 2. It says configure GLBP authentication. It says similar to hot standby routing protocol, HSRP, and virtual router redundancy protocol, VRRP, you can configure GLBP authentication to prevent rogue devices from becoming AVGs or active virtual forwarders, AVFs, in this task. You will first configure each GLBP router to authenticate by using a plain text string. You will then reconfigure each GLBP router to authenticate by using an MD5 hash of a plain text string, okay? So yes, we want to configure authentication on our devices to prevent a rogue device from being able to plug in and being able to wreck our network essentially, or being able to, you know, sniff our traffic, etc. All right. So if we, you know, it says we're going to do a plain text string first. So our plain text password will be sent in plain text. So we do not want that, because if we have somebody on the network and they're sniffing our traffic with a network analyzer such as Wireshark, they will be able to see our password sent in plain text and be able to configure that on a rogue device if they were to plug into the network, into this switch right here, okay? So if we use a MD5 hash, if they were sniffing the network, they would see the encrypted password being sent over the network, and they wouldn't know what that password was, okay? So let's go ahead and get into number one. It says on R1's Ethernet 03 interface, configure GLBP group 10 to authenticate with a plain text string of my$80 $0NL485. What messages do you notice on the console of R1 and consoles of R1, R2, and R3? Well, it's going to complain that that a password is on R1 but not on R2 and R3. So we're going to see that as debug messages within the CLI once we configure this plain text password on R1. Okay, so let's do GLBP 10. Let's do context sensitive. Let's do authentication. We want to do a regular plain text password of my$80 $0N capital L 485. Okay, hit enter. All right, and we should be seeing the we're getting the bad authentication messages from R2 and R3 because we configured a plain text password on R1 and not on the other devices. Okay, so it says on R3, display brief information about GLBP. What virtual gateway state is R3 reporting? Which router is being reported as the standby? So let's go to R3 and let's do a do show GLBP brief. And we can see that it's showing as the AVG now because it's not able to see R1 because R1 has the plain text password and R3 doesn't. So now R3 thinks it is the active virtual gateway for the group, and it's showing as R2 as the standby because R2 also doesn't have that plain text password. Okay, so it says on R1, display brief information about GLBP. What router is the AVG according to R1? Which router is the standby router? So let's go to R1. Let's do a do show GLBP brief, and you can see R1 is also saying that it is the active virtual it is the active virtual gateway, and the standby router is unknown. It should be R3, but since R3 does not have that plain text password, it doesn't see R3 anymore, as we can see. Okay, so it says on R2 and R3's Ethernet 03 interface, configure GLBP group 10 to authenticate by using a plain text string of my$80 $0NL485. What debug output do you notice on each router? So let's go to R2 and do GLBP 10 authentication. We want to do a regular plain text password of my$80 $0N capital L 485. Hit enter. All right, let's go to R3 and do the same thing. Let's do a GLBP 10 authentication text my$80 $0NL 485. Hit enter there. All right. So now we can see that it says what debug output do you notice on each router? So let's see what we got on R2. R2, you can see it now has went into the it has a lot of debug output. It is now the listening state for R1's I'm not sure. What debug output do you notice on each router? All right, so you see the debug output saying that it is basically it now sees R2 it now sees R1 and R3, and R3 now sees R1 and R2. Okay, so that's good. Let's go to move on to number 5. It says on R1, verified authentication method is being used on GLBP. So let's go to R1. Let's do a do show GLBP. All right, and we can see that plain text password is right here. So we confirm that it is using the authentication text password, but it's being sent in plain text. So anybody with the network analyzer can see this password, okay? So it says on R1, R2, and R3 Ethernet 03 interface, remove authentication for GLBP group 10, okay? So let's do a no GLBP 10 authentication of text. We want to do a my 80 $0 in capital L 485, and let's not hit enter yet. I'm gonna do that on all of the routers, and then I'll hit enter on them individually. Let's do a GLBP. Let's do a no GLBP 10 authentication text of my 80 $0 in capital L 485. Let's do the same thing on R3. Let's do a no GLBP 10 authentication text my 80 $0 in capital L 485. Let's hit enter. Let's hit enter. And let's hit enter. All right. Now it says on R1's Ethernet 03 interface, configure GLBP 10 to authenticate by using an MD5 hash of the plain text string of my 80 $0 in L 485. Okay. And then step 8, it also says on R2 and R3's Ethernet 03 interface, configure GLBP group 10 to authenticate by using an MD5 hash of plain text key string of my 80 $0 in L 485. Okay. So I'm going to do all of that in both of these 7 and 8 right now within each of the routers. Okay. So we're going to do a GLBP 10 authentication. We want to do an MD5. We want to do a key string of my 80 $0 in L 485. And let's not hit enter yet. Let's do the same thing on R2. Let's do a GLBP 10. Let's do an authentication of MD5, a key string of my 80 $0 in L 485. Let's do the same thing on R3. Let's do a GLBP 10 authentication, MD5, key string of my 80 $0 in L 485. Hit enter on R3, hit enter on R2, and hit enter on R1. All right. Now it says on R1, verify the authentication method being used on GLBP. So if we do a do show GLBP, we can see now that the authentication is in use, but it's using MD5 key string, and we're not able to see the password, so it's encrypted. So anybody that's using a network analyzer now would not be able to see that password being sent over the network. So that is what we want, okay? So this looks like the end of the lab. So let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.